Hello everyone. Welcome to today's video lecture of object-oriented programming using Java. The paper code is CS504A. This is Shiny Chandro, Assistant Professor of Department of Computer Science and Engineering of Guru Nanak Institute of Technology. Let's look at today's lecture contents. Today we will learn about two new keywords, throw and throws. After that, we will learn how to use finally block in an exception handling program in Java. So let's go to the first topic of our today's lecture, which is how to use throw keyword in an exception handling program in Java. So far, you have only been catching exceptions that are thrown by the Java runtime system. That means the exceptions that have been generated inside the program due to some logical mistakes. However, it is possible for your program to throw an exception explicitly using the throw statement. It has a general form. Let me write it down first. So here I have written the throwable instance, and this is the throw keyword that can be used to throw an exception on your own. Now, this throwable instance must be an object of type throwable or a subclass of the throwable class. Primitive types such as int or char, as well as non-throwable classes such as string and object, cannot be used as exceptions. There are two ways you can obtain a throwable object: using a parameter in a catch clause or creating one with the new operator. The flow of execution stops immediately after the throw statement. Any subsequent statements are not executed. The nearest enclosing try block is inspected to see if it has a catch statement that matches the type of exception. If it does find a match, then control is transferred to that statement immediately. If not, then the next enclosing try statement is inspected, and so on. If no matching catch block is found, then the default exception handler provided by the Java runtime system, that is JVM, halts the program and prints the stack trace. Now let us show you an example program that creates and throws an exception. The handler that catches the exception rethrows it to the outer handler that you will see in the program. So this is an example program that demonstrates how the throw keyword works in an exception handling program in Java. This program gets two chances to deal with the same error. First, inside the main method here, this main method sets up an exception context and then calls this demoproc method. The demoproc method then sets up another exception handling context. That means this method sets up another exception handling context here inside this try block and immediately throws a new instance of null pointer exception, which is caught on the next line here. And in this line, you can see that the exception is rethrown. So just like any other program, this program starts by executing the main method. Inside the main method, there is a try block. Inside the try block, the demoproc method is called. So whenever this demoproc method is called, the control will be at once transferred to the method demoproc, and it is made static, so you don't need to call it using object. You can directly call it as you are within the same class. Inside the demoproc method, you can see that another try block is there, and inside that try block you can see that a null pointer exception class object has been thrown forcefully, and that object has been created by using this portion. That means by using this new operator, and the throw keyword is used to forcefully throw the null pointer exception. That means your code is not going to generate any logical errors, and for that no exceptions are being generated. Rather, you are forcefully throwing an exception on your own using this throw keyword. And you all know that in order to throw an exception, basically you have to throw the object of an exception class, and you are creating the object by using this statement. That means by using this new operator. Then after that, there is a catch block here. So this catch block will handle this null pointer exception that has been thrown forcefully using this system.out.println statement. And after this statement, the throw keyword is written again along with the reference variable e of this null pointer exception class type. Now here in this statement, this null pointer exception has been rethrown again, and it has been rethrown to whom? It has been rethrown to the outer handler. Now who is the outer handler? Main is the outer handler. So this exception will be rethrown to the main method. That means it should be caught inside the main method again. That's why this catch block is mentioned inside the main method. Now this catch block will handle this rethrown exception using this system.out.println statement. So this is how you can throw an exception on your own. That means you can throw an exception forcefully on your own without doing any coding mistakes or any logical mistakes in your code. And that can be easily done using this throw keyword. Now let me show you the output of this program. So this is the output that we are getting. The first output is caught inside demoproc. This output is being produced due to the catch statement mentioned in the demoproc method, and this second output is being shown due to the catch block mentioned in the main method. That means once the null pointer exception object E has been rethrown from demoproc to main, inside the main it should be caught, and it has been recaught inside main. That's why this output is being displayed, and we have printed the value of the reference variable E. That's why this description is being printed. So this is the output that is being generated if we compile and execute the program. Now you may ask, what is the function of this value demo? Now let me go back to the program. This program also illustrates how to create one of Java's standard exception objects. Now, you have already seen this statement where I have already told that inside this statement, we have forcefully thrown a null pointer exception on our own by creating an object of the null pointer exception class. Here, this new operator or this new keyword is used to construct an instance of the null pointer exception class. Many of Java's built-in runtime exceptions have at least two constructors, one with no parameter and another one that takes a string parameter. When the second form is used, the argument specifies a string that describes the exception. So as we are here using the we are using this string parameter, that means that we are actually using the constructor of this null pointer exception class that takes a string parameter as input. And as we are using that constructor, so we have to give some value, or more specifically some string value, into the parameter of that constructor. And that's why this string value has been given, which is demo, that will be passed to the parameter, to the string parameter of the null pointer exception class constructor. And that is why the string is being displayed whenever the object is used as an argument to print or println method. That's why we have seen that whenever we are printing the value of E, this demo is being printed. That means the fully qualified class name java.lang.nullPointerException is being printed. After that a colon is given, and after that this string value is being displayed. You can also obtain this value demo by a call to the getMessage method, which is defined by the throwable class. Now let's go to the next topic of our today's lecture, which is throws keyword. Now let us describe first how to use this throws keyword in your program, and why do we need to use the throws keyword in a Java program. If a method is capable of causing an exception that it cannot handle, then it must specify this behavior so that callers of the method can guard themselves against that exception. You do this by including this throws clause or throws keyword in the method's declaration. A throws clause lists the types of exceptions that a method might throw. This is necessary for all exceptions except those of type error or runtime exception or any of their subclasses. That means this is necessary for all exceptions except the unchecked exceptions. That means this is necessary for all the checked exceptions. All other exceptions that a method can throw must be declared in the throws clause. If they are not defined like that, then a compile time error will be the result. Now there is a general form of a method declaration that includes a throws clause. Let me write it down first. So this is the general syntax of using this throws clause in a program. Here you can see that this is the return type of a method, this is the method name, this is the parameter list of a method, and this is where we should use the throws clause. And after that, exception list has been used. This exception list is a comma separated list of the exceptions that a method can throw. Now let me show you a program first, which is an incorrect program that tries to throw an exception that it cannot catch. Because the program does not specify a throws clause to declare this fact, that program will not compile. So let me show you the incorrect program first to you. So this is the incorrect program that I was talking about. So here you can see that this is the main class and this is a static method show which has a system.out.println statement inside it. After that, the throw keyword is used in order to throw an exception forcefully, and the exception that we are throwing by creating its object using this new operator is illegal access exception. And after that, the main method is used, and inside the main method the show method is being called, which is this one. Now this program is going to give you an error because this illegal access exception should be caught inside the program. That means this illegal access exception should be handled inside the program by the user using try and catch blocks. If you don't handle this exception on your own, then the Java runtime system will not be able to handle this exception because this is an a checked exception. And I have already told that all the checked exceptions must be caught somewhere in your program. If you do not catch the checked exception that has been generated in your program, then you should intimate that using the throws clause. That means if this checked exception has been generated inside the show method, then that show method should have an exception handling mechanism in order to handle this checked exception. If it cannot handle this exception, then it should intimate the other methods or the outer handlers present in the program that it cannot handle this exception. So that outer handler has to handle, and it can do this by using the throws clause after the method declaration. But here no throws clause is there. That's why this program is going to give you a compile time error. Now let me show you by executing this program. Just as I told that there is an error, and the error description is unreported exception, illegal access exception, and this is what the error reads like. And why the error has happened? Because this illegal access exception is a checked exception, so it must be caught inside the show method, or if the show method is unable to catch this, then it should be declared to be thrown using the throws clause. And that is why this compile time error is being shown here. So we have to make some changes inside the program in order to make it executable. Now here, in order to make this example compile, you need to make two changes. First, you need to declare that This illegal access exception is being thrown by this method, that is the show method, and that you can do by using the throws clause. And another change that you have to do is that main method must define a try catch statement that catches this exception. So these are the two changes that you need to do in your program in order to make this example compile and then execute. Now let me correct the program for you. So this is the corrected version of the previous program, where you can see that the show method has defined that this method is throwing a checked exception named illegal access exception, which it cannot handle, and it is doing that by using the throws clause. After that, the same things are written inside it, which is a system.out.println statement, and after that the exception is being thrown forcefully by this throw keyword. So basically here the show method is throwing an object of the illegal access exception class. Now main method should have a try catch block in order to handle this illegal access exception, because it has been thrown by show method, and it has already declared to main that it is unable to handle this exception. So main has to handle this illegal access exception, which is a checked exception. That means try catch blocks must be defined inside main. That is why the try block is defined inside main, inside which the show method has been called. Whenever this show method is being called here, the program control will be at once transferred to this show method. Inside it, the system.out.println statement will be executed first, and after that this throw keyword will throw the exception forcefully. Now the compiler will see that a throws clause is already there. So in order to handle this illegal access exception thrown by using this throw keyword, it will at once go to the catch block of the main method in order to handle it. And inside the catch block, a simple system.out.println statement is written, and the value of the reference variable e has also been printed. So this will be the output, which will be the second output. The first output will be inside show method. Whenever this show method will be called from inside the try block of the main method, after that this catch block will be executed whenever this statement is being executed. So let me show you the output of this program now. Now see, there are no compile time errors, and the program has successfully compiled and executed. This is the output that we are getting from inside the try block of the show method, and the next output that we are getting from the catch block mentioned inside the main method. So this is how the throws clause is used in conjunction with the checked exception. So we have seen that whenever we are using checked exception inside a method, and if that method is unable to handle the exception, then it has to use the throws clause in order to indicate the other methods or the outer handlers present in the method program that it cannot handle the checked exception that has been thrown inside its body. So that outer handler has to handle the exception. Now let's go to the next topic of our today's lecture. And the next and last topic of our today's lecture is finally block. Now let me explain first what are the conditions when the finally blocks need to be used in a Java program. When exceptions are thrown, execution in a method takes a rather abrupt, non-linear path that alters the normal flow through the method. Depending upon how the method is coded, it is even possible for an exception to cause the method to return prematurely. This could be a problem in some methods. For example, we can say that if a method opens a file upon entry and closes it upon exit, then you will not want the code that closes the file to be bypassed by the exception handling mechanism. The finally keyword is designed to address these kind of issues. Finally creates a block of code that will be executed after a try catch block has completed and before the code following the try catch block. The finally block will execute whether or not an exception is thrown. If an exception is thrown, the finally block will execute even if no catch statement matches the exception. Anytime a method is about to return to the caller from inside a try-catch block via an uncaught exception or an explicit return statement, the finally clause is also executed just before the method returns. This can be useful for closing file handles and freeing up any other resources that might have been allocated at the beginning of a method with the intent of disposing of them before returning. The finally clause is optional. However, each try statement requires at least one catch or a finally clause. Now, let me show you an example program that shows three methods that exit in various ways, none without executing their finally clauses. So this is a program that is an example program of the finally block. Here you can see that there are three user-defined methods in this program. The first one is proc A method. The second one is proc B method. The third one is proc C method. And the last one is the main method. So let me explain you first how this program is being executed. So obviously the program execution takes place starting from the main method. Inside the main method, there is a try block, and within the try block, the proc A method has been called. So the program control will be at once transferred to the original body of the proc A method, which is this one. You can see that inside the proc A method, a simple try block is written. Inside it, a simple system.out.println statement is written, and after that a throw keyword is there, which will throw an exception object of the runtime class. That means this proc A method prematurely breaks out of the try by throwing an exception. The finally clause is executed on the way out. That means whenever this throw keyword is used in order to throw an exception object of the runtime exception class, obviously the program control should at once transfer back to this catch block. But before transferring this flow of execution from this try block to the catch block mentioned inside main, this finally method will be block will be executed. That means at first inside proc A will be the output. After that proc A's finally will be the output. After that this catch block mentioned inside the main method will be executed in order to print the statement that has been written inside this system.out.println statement. So this is how the proc A method works. Now let's go to the next method, that is proc B. Now, whenever this proc B method is called from inside main, the program will be at once transferred to here, the program control. So inside the proc B method, there is a try block, and here we can see that no exceptions are generated inside the try block. Instead, a return statement is there. So whenever there will be a return statement within the try block, then the program control will be at once returned to its calling method. That means the main method. The program control should at once return back to the main method. But before returning, this finally block will be executed. That means at first inside proc B will be the output. After that proc B's finally will be the output. After that this returning will take place, which will take the program control back to the main method, where the program control will find that another method, which is the proc C method, has been called. So whenever this method calling is there, the program control will be transferred back to this body of the proc C method. Inside the proc C method, a try block is again there, inside which no exceptions are being generated. So inside proc C will be printed, and after that a finally block is there. That means the finally clause will be executed normally just after this try block. So proc C's finally will be the next output, and after that the program will terminate. So this is the flow of execution for this program. Now let me show you the output so that it becomes clear to you. So this is what I just described. The first output is inside proc A from inside the try block of the proc A method. This is the output of the finally block of the proc A method. This is the output from the catch block that is mentioned inside the main method. This is the output from the try block of the proc B method. This is the output from the finally block of the proc B method. This is the output from the proc C method. This is the output from the finally block of the proc C method. So this is the flow of execution of this program. So here I close today's lecture. In the next lecture, you will see how to create your own exception class. Thank you for listening to today's lecture. See you in the next lecture.